Okay, so the problem says that the population of colony of mosquitoes obeys the law of uninhibited growth. There are 1,000 mosquitoes initially, and there are 1,800 after 1 day. What's the size of the colony after 2 days? And how long is it until there are 70,000 mosquitoes? So I'm just going to do this second part instead of both questions. But in order to answer either one of these questions, we first have to find out what K is, or what the rate of growth is here. So here's the equation. This is the equation we're going to follow. It's the law of uninhibited growth. A of t stands for the amount after a certain amount of time. So we're going to use 1,800 for that, because that's the amount that we know after 1 day. So 1,800 goes in the A of t spot. And then A sub 0 is the initial amount. So that's going to go in the 1,000 is going to go in that spot. And then E times E raised to the K times 1, because t is 1 day. So if we divide both sides by 1,000, we're going to get 1,800 over 1,000 on this side, and they go away on the right side of the equal sign. We simplify 1,800 over 1,000 is 1.8. That equals e to the k. And then if we ln both sides, then the ln of e cancels, because they undo each other. We just have the ln of 1.8, and then to find out what k is, we just type in our calculator the ln of 1.8. And this is k right here, 0.587786666. Then we can use that k to answer this question. How long is it until there are 70,000 mosquitoes? So we put the 70,000 this time in the A of t spot, because that's the amount after a certain amount of time, equals 1,000, because that's still the initial, times e raised to the k, here's our k that we just found in the last part, times t. We divide both sides by 1,000. 70,000 over 1,000 is 70, equals e raised to the k times t. ln both sides, because the ln of e cancels. And that brings this stuff down from the exponent spot. Divide both sides by what k was, and this is what you type in the calculator, which is about 7.2 days.